In the previous example, we have talked about a group of SP students scoring an average of 72.8 marks in the test. So you can calculate the mean as well as the standard deviation to look at what is the average score as well as the spread of that score in the group of SP students. Now, if we have another group of RP students taking the same test and that they have a mean score of 69.3 marks, can you conclude that SP students score better than RP students in this case? What kind of information do you need to make such a conclusion? And what kind of tests would you need to do to make sure that the differences that you observe is statistically significant? This brings us to the next topic on statistical analysis. You will find that in a lot of experimental studies, statistical analysis is needed in order to make sense of the results, to show if the conclusion that we want to draw is significant or not. This is a flow chart to show you the common statistical tests that can be used and under what specific context will they be used. The outcome variable are typically the variables that you will be measuring, whereas the exposure variables are your independent variable, the variable that you'll be changing in order to see if it has an impact on the outcome variable. Or outcome variable can also be called dependent variable. If you are not sure what this means, please refer to the previous lectures that talk about types of data. For outcome variable that are continuous, as we have discussed previously, continuous means that is a quantitative number that can take up decimal places. These are continuous variables. If the outcome variable is continuous, depending on the type of exposure or the independent variable, then these respective tests would be used. And we'll talk about each one of them more closely later on. Now you see here that there is two different types of tests, normal and skewed. Whether or not you use this type of test or this type of test would depend on whether the results that you get follows a normal distribution or a skewed distribution. It may not be easy to interpret normality, although there are specific tests that you can use. A lot of times normality is simply assumed. Categorical outcome variable will have other sets of tests that you will use in order for you to look at the statistical significance. It will also be dependent on the type of exposure or independent variable that is used in the experiment, and we'll also talk about a few of them in this particular course. However, for the context of most of your FYP project and experiments, most of the time you'll be dealing with continuous outcome variable. So these are the more common tests that you'll be using. When you are doing an experimental study, typically people will talk about hypothesis. How do you test the hypothesis and find out the p-value? Before you start a study, you will typically have a null hypothesis, and the null hypothesis would state that there is no difference or relationship between the variables that is being measured, and whatever minor differences that you observe is due to chance alone. That is what we call the null hypothesis, simply saying that there is no relationship or no difference observed. You will also have an alternative hypothesis, which would state that there is a difference or there is a relationship between the variables that is being measured. And usually, this is the hypothesis that you want to investigate in the particular experiment to find out if this alternative hypothesis is supported. The p-value that you obtain based on the statistical test that is used would be used to evaluate how well your data support the null hypothesis. And when we talk about significance level, or the alpha, it is talking about the probability of rejecting the null hypothesis when it is true. Typically, this value is set to be 0.05 or 5%. Now, when you are reading papers out there, you may come across these phrases, and they're actually pretty much saying the same thing, although they are saying it from a different angle. When people say that the finding is significant at the 0.05 level, or when people say that the alpha level is 0.05, or simply alpha equals to 0.05, or that the p-value is 0.05, or the confidence level you have is 95%, or saying that there is a 95% certainty that this result is not due to chance or error. These are pretty much pointing in the same direction. They are just phrased differently.